Hey class, this video is on graphing linear inequalities. Now you've graphed linear equations before. The only difference between an inequality and an equation, if you look over here, is instead of an equal sign, we have an inequality symbol. So like less than, greater than or equal to, less than or equal to, or greater than. So I'm going to work out 4 examples on how to graph them. The only difference is that instead of graphing a line, we are graphing a line, but with an addition, we're shading in a specific region. Okay, that satisfies the equations. All right, so typically when you graph, you have them in slope-intercept form. I have an equation in slope-intercept form over here. We have some other strange-looking things over here, and I'm going to talk about how to graph those. Now, in slope-intercept form, we have y equal to mx plus b. Again, the m is the slope and b is the y-intercept. So if I look at this first one, y is less than 2 over 3x plus 4. The positive 4 tells me that's my y-intercept. That tells me I'm going to graph it. I'm going to put a point on the y-axis at positive 4 right over here. Well, since my slope is 2 over 3, that means I'm going to rise 2 and run 3. So from this point, I'm going to go up 2, or it looks like we're going by 2 units. So up 2 and over 3. 1, 2, 3 right here. Right? Our unit is right over there. So we're going to go up 2 over 3, up 2 over 3. And we're going to have a line that closely looks like this over here. All right, well, before I show you what that line should look like, I'm going to show you some properties that we have when given inequalities. So if you look over here, our symbol was, it was less than. All right, well, if it's ever less than or equal to, what you do is you have to shade. You shade below the line. So whatever line I graph, I'm going to shade below it. If you have a greater than or equal to, in the opposite sense, you're going to shade above. Now, these inequality signs, they tell me something else. They tell me where to shade, but they also tell me what type of line we have. So if we ever have less than or greater than, it's going to be a dashed line, meaning we're not including the points that are actually on the line, just the things that are either above or below it. Now, for these two, we have less than or equal to and greater than or equal to. The equal to tells me we're going to include the stuff on the line, those points on the line. So that means that's going to be a solid line. All right. So if I were to graph this, it looks like this, meaning that that line that we have, good, that tells me that what line we're using. But since it was less than means I shade below it. So you see all this region shaded below. And also it told me what type of line. Well, since it was less than, we didn't have that equal to. We did a dashed line here, right? Okay. Let's look at this next one. Y is greater than or equal to minus 3, or minus x, sorry. Now, if we look at this and compare it to slope-intercept form, good. Our slope is the number that's in front of x. Well, in front of x, there should be a 1. If you never see the number in front of a variable, it's always a 1. Well, in this case, it makes it a negative 1. So that means I'm going to go down 1, and that's the right one. Down 1 to the right one. Down 1 to the right one. And usually our number that's by itself is our y-intercept, but I don't see one over here. Well, if you don't see one, that must mean that it's 0. Okay, so that means our y-intercept is probably going to be over here. 0 right over here. That means I'm going to go down. So that's my y-intercept. But our slope tells me I'm going to go down 1, and that's the right one. Down 1 to the right one. So I'm going to get a line that looks something like this over here. Now we can ask ourselves the question. Will it be a solid or dashed line? Well, it's greater than or equal to. Well, since it's greater than or equal to, if I look over here, greater than or equal to tells me it's going to be a solid line. Oops, and where do I shade? I'm going to shade above it. So now let's reveal what that graph looks like. Good. So it looks exactly like this. It's a solid line, right? This is not dashed, and we shade above it. So kind of just think a range is kind of going on this line. All that stuff would be above. So we're shading all this region. If I were shading over here, it would be less than. I'd be shading below. All right. Now these last two are special graphs. All right. This one, when it's y is less than or equal to 3, whenever you have like y equal to a number, that means it's going to be a horizontal line. Right? A horizontal line meaning it has a 0 slope. And we have to find where 3 is on our y-axis. So if I look over here, 3, positive 3 is going to be somewhere right over here, right? We have 2 and 4, so 3 is somewhere right over here. And it's going to be a horizontal line. Now if we look at this, will it be dashed or solid? Well, it's going to be solid because it's equal to. And since it's less than tells me we're going to shade below. So I'm going to shade over here. So let's reveal that graph. Right over there. Bam. Given to you. So we have y is less than or equal to 3. Solid line, shade below it. That's it. Now, when we have x equal to 5, this is a very unusual graph. Whenever it's x equal to a number, it means it's going to be a vertical line. So it's what we call an undefined slope. It just goes straight up and down. And we have to find where 5 is on our x-axis. Well, on this axis over here, positive 5, I'm going to go 5 to the right. And it's going to be a vertical line going through that. So, let's see what it looks like. So, I'm going to ask myself a couple of questions here. So, we can't shade above or below, right? Because it's a vertical line. It's dashed because it's greater than. But why did I shade to the right? Well, it says x is greater than 5. Well, you might want to pick some numbers that are greater than 5. So, some numbers that are greater than 5, well, 6, 7, 8, 9, 10. All of these numbers, if you notice, are all to the right of that. So, that's why we shaded all to the right. Right, I did not shade to the left because 4, well, that's not greater than 5. 3 is not. So, all of this stuff does not satisfy this statement. All right, and that's it for graphing linear inequalities. All right, thank you.